Oh, I think I don't know what happened to my computer today. It's very slow. Probably I'll stop my video. Okay, if you have any question, you just if you have any question, you just write it in the chat box. Okay. Okay, let's get started. So first, let's talk about cylinder. So what's a cylinder? Cylinder is a surface that is a surface or lies parallel to a given line. This given line is passing a plane. Probably you don't have to memorize the definition. Anyway, I just show you more pictures, and then you know what I mean by that. It's kind of you have a you first you have a line, right? All the other line is parallel to this line, but it's not in R2. It's in R3. You can move, like here, everything, every line is parallel to this line. Okay, so let me draw a picture for you. Okay, so let's look at examples. For this part, you just look at the examples. Okay, the first one is x squared plus y squared is r squared. So r is greater than 0. If you think, okay, it's hard to imagine, you just assume r is 1. I think I already showed you this problem before. You can say, okay, you can sorry today because I don't know what happened today. My internet is so bad. I didn't do anything. Okay. And every time I get out, and then, okay. So we have examples. X squared plus y squared is r squared. R is greater than 0. And then, okay, someone is talking to me. There is a delay. I think so. But it says my internet is bad today. Okay, let me close my another computer. Okay, just use one computer today. Now, is it better, Peter? Is it better? Okay. Okay, because I use 2 computers, Okay, I closed my another one. Just focus on this. So, if you look at this, you can see Z. I said, for any Z, the picture is like this. For any Z, the picture is like this. And for example, when Z is 0, when Z is 0, okay, we get x squared plus y squared is r squared. And then what this is when there's zero, we so let's draw a picture. So it should be a circle in x, y, z, x, y plane, right? This is the circle. When z, for example, when z is 1, you just move this circle upward by 1, and then you get another circle. If z is -1, you just move down this circle like this. Finally, you collect them together for opposite z, but you know, this just go up infinity, go down infinity. Okay. Finally, we say this is a cylinder. This is, you know, what we use. We will use a lot. You know, you have to, you know, keep this in mind for the future. Okay. So this is about the cylinder. You can say by the definition, there is a line in a plane like here, right? And all the other line is parallel to this line, right? That's the definition of the cylinder. Anyway, you don't have to care about the general definition. You just memorize this. And anyway, that's fun for our course. Okay. You might say in the future, you know, for example, I give you remark, you imagine this. X squared plus z squared is r, like this. Y squared plus z squared is r squared. You draw this by yourself after the class. It's the same, just get some training. That's fine. Okay. Let's continue. This is about the cylinder. Okay, let's cylinder. And then let's talk about the or quadratic surface. The book he just used quadrics. Anyway, they're the same. So in general, you know, if you study a little bit of linear algebra, okay, that's fine. If you don't study it, okay. So in general, the book say, okay, if ax squared plus by squared plus cz squared plus dxy plus exz plus fyz plus f def g x g h y I, Z, K is 0 if the surface is determined by this, and we call it we don't need that part. We just show you an example. You understand all examples. That's enough for this part. Okay, so let's look at one more example. Plus line y squared plus 4z squared is 1. So this is called ellipsoid. So this is called ellipsoid. So the problem is that, okay, how do we draw a picture? I don't know, but anyway, let me first finish this. How do we draw this picture? First, you can say x, y, z cannot be very big, right? If it's too big, it cannot be right. For example, x is 100, because every term is positive, means x, y, z cannot be big. Okay, just should be some small. And then let's look at this picture. We can first try when z is 0, you will find, okay, x, y plus y squared over 9 is 1. What's this? This is a ellipse, right? It's kind of when z is 0, you get an ellipse on xy plane, right? I think you, for example, z is 1, you draw this, okay, sorry, you get an ellipse like this. This is the ellipse. But then you, from this, you can say z has to be less than 2. If z is greater than 2, this cannot be right? And then you have to be like this. And also for any z, and also you can say z, when absolute value of z is 2, you will find x squared plus y squared over 9 is 0. This just points, right? Just x is 0, y is 0. So, and then for any z is between 2 and 0, it's kind of less than 2, we can get x squared plus this is 1 minus z squared over 4. This is still an ellipse, just because the ellipse get, thinner and thinner. So, for example, when z is 1 or 0, this ellipse. When z is smaller, just because the ellipse gets smaller, finally, when z get to 2, x, y, z become a point. So, by this, we can draw a picture. Okay, when z is 0, this is the ellipse, like this. When z gets bigger, your ellipse gets smaller, like this. When get smaller, smaller. Finally, you get your ellipse kind of like this. Right. I think this is kind of American football, right? You can imagine it, right? Right. So, where in general, people try to, okay, it's easier to draw, okay, in this way, okay, let's see. That many way. Right. This is ellipse. So the special case remark, this kind of equation is x squared plus y squared plus z squared is 1. It's kind of the coefficient in front of x squared, y squared, z squared are the same, but this time it's a sphere. You can say the ellipsoid sphere is a special case for the ellipsoid. In general, ellipsoid is like this. Okay. So this is about the first example. So let's continue. So it's kind of, I'm teaching you how to draw a picture. I know this should be very hard. So the example, if z is 4x squared plus y squared, this is called the elliptic parabola. So z should be greater than 0 because z is 4 squared plus y squared. Z cannot be negative. 0, right? If z is 0, that's 4x squared plus y squared. Right. And then you can say if z is greater than 0, this is 4x plus y squared is z. For example, we assume z is 1. You can say, okay, let me draw a picture here. X, Y, Z. You can say when z is 0, just 1 point, right? As z get bigger, for example, z is 1 at this place. What's this? It's an elliptic. Oh, ellipse. And then we get a third like this. And then as z, for example, 4xy plus y squared equals to z is 2, you get a bigger, the ellipse get a bigger. Right? And then as z gets bigger, it's bigger. So finally, the picture should be okay like this. I screwed, right? I think so, right? So this is the elliptical problem. So the z direction should be changed dramatically because z is kind of the square as s get and y get bigger. Z will get much bigger. For example, x is 100, z is y is 100. Your z should be 10,000, right? It's not the straight line. It's not the straight line. Should be above. This is about the elliptical paraboloid. And then let's look about another example. So this time is z squared equals to x squared over 9 over 4 plus y squared over 9. This time, this is called a cone, right? So let's draw a picture. Here, right? It's squared. From this, you can say they can be positive and negative. So when we are drawing a picture, if we know the picture for z is greater than 0, automatically we will know the picture for z is less than 0, because it just flip the picture from above to below. That's kind of easy, right? So let's first deal with z is greater than 0. So of course you can say when z is 0. Okay, when z is 0, what happened? So when z is 0, x, y is 0, kind of point. And then when z is greater than 0. Okay, for example, when z is 1, so this is 1 over like this plus this. When z is 1, you get an ellipse like this. You get an ellipse like this. And then when z is 2, we get 4 squared of 1 over x squared plus 9 over squared. You get another ellipse. And then continue the same way we get the picture. So I will compute this, directly. So this time the picture should be like this. Unlike this, it's kind of the problem. This is the straight. You may say, okay. You may say, why? The reason that this is z squared. when x grows linear, they have to also grows linear because there is a square, right? But here is different. When x grows, grows linear, they will grow radical, right? That's why it goes through faster. Here is the same. And then if we look at the part for this greater than 0, you just flip this picture, right? And then we go up. This is a cone. This is our picture. Okay. This is for z is greater than 0, z is less than 0. To be honestly, because I know that so let's continue. Example, this one is quite hard. It's useful for our future. Okay, this is y. This is y squared minus x squared. There is a name. It's called a hyperbolic paraboloid, right? So this problem is very tricky. So what's the picture? Like this. You can say for this problem, they can be positive and negative, right? No kind of this example is totally different. The reason that this is a minus, right? If it's plus, okay, that's fine. But it's minus, this is quite hard. And also we just imagine what's this. You can say this time as z equal to 0, we get a y squared minus x squared is 1. And then we know y minus x, y plus x, sorry, is 0. So we got a y is x, y is negative x. So we know by this, we know when z is 0, you get 2 9 in xy plane, right? Right. You can just forget the 3 dimension. Okay, it's kind of okay. Now we are in R3, right? No, now we are in xy plane. You can pretend okay, there is a z direction upward, like here. Okay, you draw okay, this is x equal to y and x equal to negative y. Okay, this and then, but you cannot move it because as they change, it changed. So, and then let's look at when z is greater than 0. We know y x minus x, for example, as z equal to 1. So we get a 1. What's this? Right, this is a hyperbolic curve, right? Like this. Okay, this is for z equal to 1. So let's pretend we are doing this in xy plane because when x equals to 1, it's a plane. This plane is parallel to xy plane, right? That's what we talked before. We can draw the picture because y is greater than x. Because this is positive, this is negative. The picture should be like this, right? Right. So but this I draw this in xy plane, but you have to lift it a little bit to z equal to 1, right? As z gets bigger, because this is quite hard to draw, Anyway, as z gets bigger, okay, for example, when z is 2, this is y squared minus x squared is 2. And then we know this time the picture should be, okay, far away, like this. Okay, just far away. Okay, maybe I should. Okay. Far away. So here, and then let's look at z is less than 0. For example, when z is -1, this is x, this is y. Okay. Y squared minus x0 is -1. So this is x squared minus y squared is 1. And then let's draw a picture. This is x, this is y. The picture, because x is positive, the picture should be like this. Right? For example, when z is -2, we get x squared plus minus y squared is 2. And then we continue to draw a picture. Just get a bigger and bigger like this. So if we combine them all together, because it's very hard, you can see as, okay, you can see as, okay, I can, and also you can see the picture in your textbook. It's very hard to draw this one. I can imagine, but it's just quite hard to draw. So when z is 0, okay, let me draw. So when z is 0, change the color. So you get 2 line, right in xy plane. And then when z is greater than 0, the picture should be like inside, go up, like this. Try to go up, because z, you can say this, z is a picture. It's kind of, the picture should be this part. Upward will go up. The main reason that I forgot, I didn't know. We don't have the video, the video. You cannot see my hand. It's kind of, you hold your hand, and then, okay, let's draw it. Try to imagine. Okay, like this. This is kind of go up like this. Go up. This part is up. Go up. And the same for this. Go up. Go up. Right. This is when z is greater than 0. If z is less than 0, the picture changed. Is same for this, but it go down in this direction. Okay, let me change the color. It goes down in this direction. Okay, it goes down in this direction. It go down in direction. I never, ride a horse. It's kind of the sad for the sad of the horse, right? And also there is another name, it's called the sad surface, like that. You can draw like this. The picture should be, if you forget the picture I draw, it should be like this. Go up. Okay, this is the horse. This is the head of the horse, right? This is in front, rear. And then go down. You are sitting here. Go down, up. This is back. This is the head direction. And for this two sides, it go down. Right, this is kind of right, left. Oh, I hope this helps you. If you can imagine, the picture should be like this. Okay. Anyway, I think this is what I can say. You just, if you say, okay, you cannot understand this, just look at the textbook. It has the, computer vision picture. Okay. So let's continue. Many pictures like that. probably I think you'll be careful. You know, I give the first quiz. I think probably the other instructor will give a quiz problem about this. Okay, he draw the picture and give the equation. Okay, try to point out or try to match the picture and the equation. Kind of this kind of problem. Okay, okay. It's very important. So let's continue. Okay, that's fine. Example. So this is 4x squared plus called hyperbolic or hyperboloid of one sheet. So let's look at this one. You can say first, we move this term to the right hand side. We get x squared over 4 plus y squared is 1 plus z squared plus 4. From this, you can say you can see z can be any number, but this part is greater than 1 because this squared is greater than 0 or equal to 0. This should be greater than 0. So means that, but z can be 0. Okay, z can be any number. You can say, okay, if z is greater than 0. Anyway, like what we did before, if we know the picture for z is greater than 0, automatically we know the picture for z is less than 0, right? They're the same, right? Because for negative z and positive z, the equation are the same, right? So let's look at z is greater than 0. 1 squared over 4 plus y squared is 1 over, we pretend this time z is 1, and then we just, like this, right? What's this? This is ellipse. So, and then, for example, z is any k, we have 1 over x squared, no, x squared over 4 plus y squared is 1 plus 4k squared, right? This is also ellipse. Just when z, the difference is that when z gets bigger and bigger, the ellipse get bigger and bigger, right? It's kind of as z goes up, the ellipse get bigger and bigger. So we can say, okay, as z equal to 0, so we get this one is an ellipse. It's not a point, right? If you look at the previous example, that's a point, but here it's elliptic. And then as z gets bigger, you get a bigger ellipse. Okay, so like this. This is z equal to 0. This is z for z bigger than 0, greater than 0. It's the same. This is not a straight line. Okay, like this. And then when z is less than 0, like I said, the picture is the same. Just draw more like this. Hyperbolic curve, right? Like this. One sheet, because we have another one, it has 2 sheets. Okay, this is about hyperboloid of one sheet. Okay. So this is one of the example. So, and let's look at one more. I know it's a low in this. So this example is 1 over x squared plus, minus plus this squared is 1. The difference is that for this one, you have 2 positive, 1 negative. You have 2 negative, 1 positive, right? We can change this picture this equation in this form. From this, you can read directly. They cannot between -1 and 1. Right. Because this has to be greater than 0. You can say, okay, read from z has to be greater than 0. And then you can say as z, the absolute value of z equals to 0, we get 4x squared plus 9y squared is 0. Right, this is just a point. When z equal to 1, that's point, not z equal to 0. When z equal, when z equals to 1 or -1, -1, you get a point. And then let's look at the case 1. If z is greater than 1. Okay, first we know. So this is x, this is y, this is z. This is z equal to 1. Goes down. This is z equal to -1. We know when z equal to 1, it's simply a point. Right? Simply just a point. And then when z gets bigger, for example, z is equal to k, k is greater than 1, we have this is k squared minus 1. This is greater than 0. This is an ellipse. It's kind of, as k gets bigger, your ellipse gets bigger. It's kind of, I just repeat what I said 4,000 times. 0 and gets bigger, ellipse. Finally, okay, you get a picture like this. For different z, it's an ellipse. Right? So this is for z is greater than the same, doesn't change at all, right? It's the same equation because if z is negative, because there is a squared, it disappears, the negative disappears. And then you can draw a picture in the same way. Okay, go down. Okay, it's bad. Go down. Okay, if you, even my drawings makes, makes the, make it the same different, but they're the same, right? You just flip the upper one to the lower one, they're the same, but my drawing is bad. If you check the picture on the textbook, there's a table, right? They're the same. Okay. So this is for hyperboloid of two sheets. Oh, yeah. I think that's all picture I showed for you today. Today, what we do, so let's do a summary. Today, first, okay, let's summary the material after the first midterm is done. We studied the equation of lines. So we have 3 types of equation. You have to know all 3 types of equations. And also today, we studied the equation for a plane. Equation of a plane. The equation should be a x minus x naught plus b y minus y naught plus c z minus z naught is 0. Okay, a b c is a normal vector field. No field. Okay. Anyway. And x naught, y naught, z naught is a point in the plane. And then after this, we talked about the, okay, sorry, about the cylinder and the quadric surface. And also for quadratics, there are many examples. I hope you can review this by yourself and try to, if you couldn't understand me in the class, I hope you can, watch the recording. Anyway, finally, I hope you can do what I do. Okay, do what I did. Okay, and also I'm going to introduce a little more about the cylinder. So because we still have time, more about the polar coordinate. So first one, we know for any x, we can write in r cosine theta, y is r sine theta. I think you know this in calc too, right? By this, we know x squared plus y squared is r squared. Y over x is tangent theta. You may say, why do you do this? So you can say, if we are in R2, right? Right? This is a circle with the radius r centered at 0. Okay, we can say if we do this, right? We said x is r cosine theta, y is r sine theta. This is r. We can say this is r cosine theta, r sine theta. What's theta? This is theta. Right? Why? Because tangent theta is y over x. Right? You can say, if you check, this is y, r sine theta, r cosine theta. Okay, you can say that's tangent theta. Oh, I hope it works for you because this is very important. I think you know this. Okay, you calc 2. Probably you forget it. I just tell you again. So this is about the polar coordinate in a plane. Okay, and then let's tell you more about the cylinder. So for cylinder, so we have x, y, z. For example, for this case, x squared plus y squared is r squared. This is the cylinder, what we are considering. Okay. So for this one, we just assume x, y is r cosine theta, y is r sine theta. Okay, r is fixed. So theta is between 0 to 2 pi. And z, it doesn't change it. We just rewrite z as z. But write x, y as r cosine theta and sine theta. It's okay. This is called the cylinder coordinate. So it's very important for our future because I want to introduce it here. Try to understand this part. Doesn't change anything. You just use the polar coordinate we started before and move it here. Add one component. Okay, that's about the coordinate. So I think this is what I'm to say. I don't have more examples for you, so I think we still have time, so we can continue. Stop recording.